Welcome everyone to the first webinar of PK. So this is going to be one of many throughout the year. Obviously today Tim's going to talk about the database and indicator updates. So he'll have quite a bit to talk through, but we're super keen to hear any suggestions or ideas that you have afterwards. So I'm just going to send through a quick survey because keen to hear what you want to know more of about PK and lifecycle assessment altogether. So thanks.
Thanks, Kat. Okay, so what I'd like to go through, let me just share my screen and let's share the big screen there. I think that's the right one. And so, as Gab mentioned, a few things that we want to. It's been a while since we've had an update webinar, so we thought we'd start that as part of this webinar series. I'm going to go through a couple of recent feature updates that were slipped into PK without much fanfare, things people had been asking for, like most of our development. Some new data that's been added. And then talk about the impact method updates and some PK5 teasers around what we can expect over the next 6 months when hopefully PK5 is ready to roll out. So my name's Tim Grant. I'm the director here at Lifecycles, and Lifecycles has been the owner, operator, and coder of PK for the last 7 or 8 years, and we're very proud to be entering our second redevelopment phase as we sort of implement new features and fun things within PK. Okay, and butt in any time if you've got any questions or want any clarification. So one of the things that new features that we added recently was a different way to add conversion processes or manufacturing processes to PK based on the area of the package. So most of the traditional conversion processes we've got, like paper making and injection molding and extruding, are all based per unit of mass relating to the packaging component that's being manufactured. But that is always difficult when you're looking at things that are looking at coatings or printing or things that are more naturally scaled to the area of the package rather than its physical mass. So we've implemented area-based conversions that allow you to add specific processes, and as a starting point, we've got, I think, 8 area-based conversion processes built into the tool, and we will add more as we go. I thought I might just share with you how that looks like in the tool. So if I come into PK and jump into a project, so if I'm looking at a package, let's say this water bottle here, I've got my package configuration, I've got the materials in the water bottle, and so here there is a plastic bottle, a cap, pallet wrap, and if in the, let's say, in the plastic, maybe if I add a label to this bottle, label, and the label is going to belong to the retail unit, and that is going to be a coated paper label. Go down and find coated paper, and it maybe weighs 2.1 grams, has 0 recycled content. And the only thing really that happens to that piece of paper is that it's printed on, but it's very hard to print on 2.1 grams of paper. So we specify the area. So we're going to use an area-based conversion rather than a recommended conversion. And in there, we can come in and saying we have a offset printing of the labels, and the label is 5 centimeters by 8 centimeters. 5/8 are 40 centimeters squared, and it's in Sweden. And we click add, and so now we've got a area-based conversion. So that is, so the other conversions we have in the area base, so 4 printing processes, and then 5 different coating processes: metallizing, powder coating, varnishing, and zinc coating. So that's the first one. The second thing that we have added, which I might just talk about while we're in here, is sometimes when you've got a complicated packaging component, the actual conversion processes, you may want to mix different conversion processes together in different fractions. So we have allowed, under the custom conversion menu, you can actually go and create a custom conversion, and I can say add custom conversion and make a new complex conversion process. And in here, let's say there is a multi-layer plastic paper film. So we need to have some let's say we want a cast film, but only half of the mass of the product actually is cast film. So we want to have cast film for 0.5 of the overall mass of this kilogram of conversion process. We might then have a varnishing coat over the top of that. And so then we are looking at the area for 1 kilogram of this process that is being converted. So we add the area base there, and maybe that's 22,000 centimeters squared. And then there might be a third process where you actually have real data. So you want some electricity from the grid that you're going to add for the last little packing process. So we can take electricity from local grid and add that to the tool. You can also use these custom conversions if you want to produce a manufacturing process that uses specific renewable energy. So you can go in and select electricity from wind or solar as part of that process. In PIQET 5, we will allow you to pick a particular process like cast film and select that all the energy inside it is renewable, so that you don't need to actually know what the energy was, but you will be able to specify renewable energy in your first layer of the supply chain. So they're just a few small modifications that we've added to the tool. So that's these layered mixed conversions and area-based conversions. There have been a few other minor tweaks, but not really worth going into in detail. In terms of database updates, so the main thing we're working on at the moment is this updating our core database, which I'll talk about in a moment. But just recently, as requests have been coming in for additional materials, we've added mycelium, which is a mushroom-based packaging material built on top of cereal and hemp straw. And it's still there is some manufacturing process going on. We are in discussion with one of the manufacturers to see if we can get specific data from them, but we've got a reasonable data from a scientific paper outlining the different process steps. Paraffin and water have been added as cooling refrigerants that are used in some passive refrigerant packages as phase change materials. We added some injection moldable zinc alloys and I think a magnesium alloy. And we've added a couple of rubber processes as well, which have been requested recently. I think on the agenda, there are a couple of new processes that were sent through from someone the other day, and I can't remember what they were, but yeah, wherever you're thinking about materials that you think you may want to have added to the tool, please don't hesitate to let us know and we'll do our best to get them in. Okay, so the larger project is updating the PIQET database, and just to remind those who haven't seen, the data that drives PIQET is based on a fundamental sort of very large database that comes from the EcoInvent Center in Switzerland. We take that data, we regionalize it to 54 regions globally by pulling it apart and substituting electricity and freight efficiencies and landfill behaviors and alike, and incorporate any additional regionalization of material and of supply chains that is available within the EcoInvent data sphere. And so we use that and we supplement that with data from other national and industry-based data sets. But for all the data sets that come from other processes, they're still built in this with EcoInvent sitting in the background. So at the moment, we're going through an update to 3.9.1 of the EcoInvent database, which came out last October from EcoInvent and arrives in SumaPro, our modeling platform, a month ago. So we're busy updating to that, which will update all of the technical processes, electricity grids, and alike. Now, the effects of that are usually relatively small. You know, within any given year, not that much happens, but there has been a few key changes, and there's actually been a couple of years since we've updated the data. So what we're seeing is, firstly, some changes to renewable energy in many economies, particularly some of the European economies. And so that's bringing down the grid mix of different countries. We then have some shifts away from nuclear and gas, partly driven by changes to policies in countries where nuclear has been seen as less favourable, and also in reaction to shortages of gas due to the situation in Ukraine and other factors. So it's a bit of a swings and roundabouts with electricity data sets. If we look at our 54 regions, what we see in the light brown is the updated values in greenhouse gas emissions, and the brown is the existing values. And so we can see something in the order of 5 to 10% improvements in many countries. If you know your 2-letter codes, you'll be able to pick which countries are which. So we see Denmark, a major drop in emissions in Denmark, and I'm not sure what EE is. It's not. But then we see some other countries which have really done very little. We see very small changes in China and India, which is 2 major manufacturing centers. So they're not changing too much. Indonesia's actually gone up in its emission profile, as has, I think, LT, could be Latvia. Yeah, so it's a little up and down. Thailand's gone up. Singapore's gone up, which is, yeah, very curious. So that has an effect not just when you use electricity or you use the conversion processes, which are very heavily dominated by electricity, but it will affect also the material supply chains that have electricity sitting in the background of them. So they will all move somewhat with that change. The other major change has been some updates on the emissions from oil and gas. So there has been some research over the last couple of years that found there is a significant leakage of methane from oil and gas fields in different parts of the world. And these emissions have meant that the overall greenhouse gas profile of particularly natural gas products has gone up by between sort of 10 and 40%, depending on the region. That data has now been flowed through into the latest EcoInvent databases, and it now flows through to plastics production. Now, of course, the impact of natural gas and energy carriers like that in plastics is not the total impact. So the actual effects on different plastics, and this is the situation in China for all the plastics in China, which did have quite a significant rise in the profile of natural gas. And what we see from the current data to the updated data, that there is rises of again between 5 to maybe 10% at the maximum for nearly all of the fossil-based plastics. And this is over a couple of years where we would have expected them to come down, largely because some of those electricity grids and other processes have improved, but we're actually getting quite a bounce in terms of not only have they not come down, they've actually gone up somewhat because of that change to the natural gas supply. When you look at the bio-based ones, which in the database, they tend, because they don't have fossil natural gas impacts, we actually see quite large reductions of maybe a third or more for EVOH and PHA and some of those natural materials. So it'll be interesting to see how that flows through to people's projects, whether it actually shifts the balance between some material choices. There are, for other materials, we're sort of seeing a bit of a mixed bag of minor improvements to data where the underlying emissions become, some go higher, some go lower. There's not really a consistent trend in other materials, and we are still sort of working through how that will flow out, and it will be different for different countries. But so that's the main efforts on the inventory updates. Any questions at this point? Okay, hearing none and not being a fan of awkward silences, I will press on and we can talk about the indicator updates. So we have been wanting to update the indicators for a fair while. It actually is not a simple task in terms of both modeling the indicators, getting the data to match and vet them, and then get them into PK. But we have a number of drivers for the indicator development. One is the changes to the European Product Environmental Footprint method. So we'd implemented their draft method from more than 5 years ago. And so since then, they've published their up to method, I think 3.1 of their overall indicator framework. And so we wanted to include that partly because we want to be able to report against those metrics, and they are probably the best worked through indicator sets that we have. but also because they offer a weighting and prioritizing process that's available for assessing your packaging options. So we're going through that. We would also, a major aim of PK5 is to allow you to produce an ISO 14044 or an ISO 14067 standard report. So moving beyond just internal comparisons and decision making to be able to produce something that is can be peer reviewed and can be a public document. To do that, we need the most recent environmental metrics to have them included in there, because if you go to peer review and you're using your impact models are outdated by 10 years, then that generally won't comply. The third thing is there are actually some new interesting indicators. There's some things happening on land use. There's also some change methods on particulate matter and acidification, and some of these methods which are actually regionalized to different countries around the world. So we wanted to have them in for that reason. But firstly, if we look at what the product environmental footprint metrics look like, so they are similar indicators to what we already had, but the actual models have changed. The units of some of them have changed. And so we have climate change, ozone depletion, ionizing radiation, photochemical ozone formation, particulate matter, 2 human toxicity indicators, acidification, 3 eutrophication indicators, ecotoxicity, land use, water use, and resource use. And I think I've missed resource use, mineral resource use, haven't I? Okay, there's one missing on there, which is mineral resource use. So they'll all be updated and included, and they're already in our beta testing phase in the tool. But if we then go to what the product environmental footprint provides is 2 weighting methodologies you can use to actually weight your indicators as part of your assessment. And it does this by taking the results that you've typically been looking at in PK, which are at the characterization level. So these are kilograms of CO2 equivalents and cubic meters of water equivalents and kilograms of PM 2.5 equivalents and alike. Dividing the results by the total impacts per year of each impact category. And so that's called normalization, where you really look at how much your product contributes to each impact category compared to all the other contributors to that impact category. And then after normalization, you actually can apply a weighting factor where we weight the different indicators based on their importance to our overall environmental aims and perspectives. You can then sum all those numbers and you end up with a single score. Now, initially when PK was developed, there was a very strong rationale to say we will not provide single scores because they're dangerous and can lead people to make oversimplified claims about their products based on very subjective weightings. So that's still, in a way, an issue within the LCA standards. Don't allow you to use single scores, to report single scores in a comparative assertion if you're releasing it to the public. But partly because the European Union has actually gone ahead and produced these indicators, and because as an audience, the LCA community and the packaging community are now much more educated in the use of metrics. We think it's that the benefits of providing these weightings outweigh the risks, and so we'll be putting them into PK into the next update in a simple way, and then they'll be available in a more complicated way for PK5. What the weightings look like interesting in themselves. So they have 2 weightings, one with toxicity indicators and one without. and that's partly because or largely because the toxicity indicators have such high uncertainty and can dominate the weighting, the weighted result, just because of their the way they get normalized, that it was thought to actually allow a weighting scheme with and without the toxicity indicators. You can see that the way the weightings are organized, every indicator gets a significant amount of weight. Nothing is like weighted down at 1% or 0.5%. Everything is generally in the 10%, the 7%. Eutrophication is sort of split across three indicators, but represents roughly 10% of impact. So this is very much a bit of a mix of science and politics built into these weightings there, where sort of you don't want to isolate any one issue as being irrelevant, but you're trying to provide some overall prioritization between different indicators. The way in which, one of the ways in which the weightings is suggested to be used, because given that you are not to use it as a declaration of environmental superiority on its own, is within the PEF process, there is a procedure to identify the most relevant impact categories that you should report on by looking at the normalized weighted results, and then picking that it basically suggests or requires that the indicators, impact categories that are identified in the top 80% of the score, once you weight them, shall be reported. So that's a way to actually, we often get asked how to choose between the different indicators that are available. And so this really gives you a way to assess your product, assess it against the weighting, and then report just things that sit in the top 80%. And you report them from the largest to the smallest contributions. And they also require that you have at least 3 categories included in any of those, in those top 3 must be included. Now in the ECHO, in the 4.3 PK 4.3 implementation, you won't be able to see how the different impact categories contribute to the overall score, but you will be able to see if the overall score varies on a dominance basis compared to other indicators. Something else which is being added to the impact mix, and this is again is for transparency within the climate change modelling, is to have a breakdown of the different contributors to climate change indicators. The current approach that we have in PK is what's often referred to as the sort of carbon neutrality assumption built into our greenhouse gas factors. And so what that means is all the greenhouse gas emissions are included except emissions directly from biomass back to the atmosphere, so the combustion of biomass or the absorption of carbon dioxide in the growing of biomass. So it's assumed under the carbon neutrality assumption that the sum of all absorptions from biomass will eventually be matched by releases of CO2 from biomass. We do include in this number the impacts of biogenic methane because it has a much stronger impact on much stronger global warming factor, and therefore won't be balanced with the opposite carbon absorption. So things typically will be absorbed as CO2 into biomass, but they can be emitted as methane. Below that one, we have 5 breakdowns, or 4 breakdowns in a total. So there's the fossil-based climate change emissions. So that will just be the emissions from all materials and except biogenic methane and biogenic carbon dioxide. So all fossil derived emissions, plus the other nitrous oxide and HFCs and CFCs and alike. There's then the biogenic emissions, so emissions from the combustion or breakdown of plant material. There is separately reported the carbon uptake from atmosphere by plants. So these are the two which are typically excluded from this top measure. And finally, the land use and land use change from the occupation and transformation of land, which can lead to a major carbon flux in terms of by having different above and below ground biomass under different land use assumptions. The sum of these four here will give you what's referred to as the climate change total, including all of these natural biogenic and emissions and CO2 uptake, which may well give you a different number to what you get under carbon neutrality assumption. If there is no net carbon stored, then the answer should be very close to the same. But if your system is maybe producing paper products, those paper products are being sent to landfill, the landfill has an assumed emission of CO2, but not all the carbon placed in landfill degrades, you will get net reductions in the overall emission profile because of that storage of paper and paper or wood products in landfill. Any questions on the PEF weighting or the climate change indicators? Nope, it's either really clear or really confusing. Okay, the other breakdown which is available within the new data sets is a breakdown of the toxicity indicators. Now, we typically haven't, I don't usually suggest going too deep into the toxicity indicators within a tool like PIQET because it's can be, they are highly uncertain and they are often derived from processes very deep in the supply chain. Sometimes it'll be metal emissions into the coating of a metal component that's part of a truck that transports something to somewhere else. So they can be 3, 4, 5, maybe 10 layers deep in the supply chain that you maybe got some metal emissions that can stand out because they are just higher than anything else that's actually being represented. But if you do have want to look at the toxicity indicators, it's now generally recommended that you provide the breakdown of the 3 toxicity indicators: human toxicity, carcinogenic, human toxicity, non-cancer, and ecotoxicity, that we break them down by contributions from organic chemicals, from inorganic chemicals, and from metals, because often it can be, you might be thinking that it's pesticides or hydrocarbons that are causing the problem, and in fact it can quite often be trace metal emissions from combustion processes, and it's helpful to be able to actually see that within each of those categories. So that sort of adds essentially takes these 3 categories into 9 categories, as you have 3 times 3 within the impact selection. So overall now, I think we have, with the climate change and the expanded PEF and the indicators, there's something like 26, something like 36 indicators being included.
Can I have a question if I could?
Yep.
Just back 2 slides to the climate indicators. For carbon that might be stored in plastic for a period of time, a plastic product, that would be that would come up and be evident in the biogenic ones, and that it wouldn't be counted there?
No, it wouldn't be counted anywhere
Yeah.
until it gets combusted. So if you have a plastic product that is made of crude oil or natural gas and then goes to landfill, the CO2 or carbon in that plastic never reaches the environment. So as an emission, so it never appears anywhere within the flows.
Okay. But
Yeah,
what if it
so
was plastic produced from biomass? So there would be an uptake from the atmosphere, and then it would go to landfill and get fixed. So
yes, exactly.
that would be and that would be a negative biogenic.
Yes, that would be you would see it as a CO2 uptake in whatever the plant materials were that were going in on the production side, and then you would fail to see it be re-emitted at the end of life as a biogenic emission. So if they, yeah.
Okay, thank you.
And that's something we haven't included. We're excluding that in this carbon neutrality assumption, and it's essentially penalising landfills by not counting the storage of carbon and biomass in landfills.
Yes,
And that was
I was wondering that. Yeah.
that was something, a decision we sort of made partly because there's high uncertainty about whether, how much carbon does get stored in landfills, and generally there was uncertainty about whether you're allowed to count that. What I sort of see now from the breakup of this thing, that we're now able to count it, but we can have that number separately reported. Any sort of what you might call temporary carbon storage within the economy, which essentially the landfill in way is could be seen as part of the economy.
Right. Thank you.
Okay. Okay. On to PK5. What we're planning, we're in advanced production. We have the interface probably 50% built, and all the back end being constructed. So a few things that we are looking to do. We're simplifying the life cycle stages. So we will be getting rid of the in the current PK, for those who came in late and can't remember, we currently have for every packaging component, when PK wakes up, part of the rationale for reprogramming is to improve speed and performance as things require over time. So if I go into PK, we currently have this thing where whenever you produce a package, we also produce a packaging contents as a sort of as partner of it. And that was because we were wanting to mix different contents in with those. We're going to get rid of that. The contents is going to move to their own projects. So you'll have contents projects, or what we'd call product projects, and package projects. And then within the package, you'll simply have one consistent breakdown of the configuration, the materials, the filling, wholesale, retail, and consumer. So they'll all sit in one line, and rather than being split across these areas. And there'll be an explicit area for dealing with end of life. At the moment, we sort of hide end of life within these retail and consumer sections. We're going to bring that out and make it more obvious where the end of life destinations and reuse is actually being modeled, rather than having it hidden. Secondly, we will be introducing a package component recyclability override. So this will allow you to, at the moment, whenever you building components, if the component's made of aluminium, at the end of life, by default, it will see that aluminium as recyclable. If it's made of polyethylene, it'll see it as recyclable to a lesser degree. What this will allow you to do is to identify that a particular component is either only acceptable for open loop recycling, or it is not recyclable because of some rationale that it's too small, or you've glued it to something else, or it's for whatever reason is not able to be recycled. The default will still be that every packaging materials into packaging components will be managed by their standard recycling rates, all of which you can adjust, but we will have this ability to override for one component while leaving another component to be recyclable. So it may be that the material in the cap you say is not recyclable because it will be fall through the sieve, while the material in the main body is recyclable, even though they're the same material. There will be enhanced organisation reporting, including the ability to put data into the tool using a data upload of your stock keeping units, or connecting directly to an API. So the API interface will be a lot more functional and specified within the PIQET 5. The reports will be fully customizable. So at the moment, we sort of produced a compact report and a detailed report, and we had a few customizable sections. In the new one, you'll basically have every element of the report will be available to include or exclude, and then we'll have some standard shortcuts to which bits you may want to include. So we'll still have a way to quickly say, give me the really brief report or give me a very long report, but we'll make all the elements in the report customizable. So you can choose whether you want a table of contents, you can choose whether you want to include the description of the project or not. And all of those leading towards being able to actually produce this a standard reviewable ISO 14040 report from your PK model. So there are some new fields, which will be text fields, which will be brought in that are required as part of the goal and scope stage of an LCA, which you can use if you're trying to produce a reviewable report. As part of an extension really of that PEF weighting system, we'll actually provide the ability to have a customizable weighting system within the tool. So here you'll be able to create your own internal organizational weighting, and that will include both life cycle indicators as well as packaging metrics. So you may want to include the circularity score and climate impacts and water impacts as three things that you want to assess and weight together. It will also, as part of the weighting system, will demonstrate to you how each of the components that are being weighted, what their overall contribution is to the final weighted score, which is quite challenging, particularly for the spider diagrams, to be able to do that. And as I mentioned earlier on, products will be modeled as separate projects just to remove them out of the space for working in packaging, while still allowing people wanting to model their product contents in the tool in a separate place. So product contents will be a little like custom materials in a sense that they will sit outside of your project, and you can bring any one or multiple products into your package at the point when you want to include it, if you want to include it. The other, we'll also have a library of common packages. So this has been requested by a few people for a while, somewhere where simple standard packages that you maybe use as a starting point for projects, you can store them in a special project, where they'll be, you'll be able to draw them from this special library project and bring them easily into your new project, so you don't have to sit there and start every project from ground zero. So so that's some of the features, and the way as part of this ISO, this, I suppose, simplifying the life cycle stages. When you first come into the new tool, what will happen is in the project scoping stage, you will actually be presented with all the different life cycle elements that are available. So end of life, consumers, wholesale filling, so forth, the different levels of packaging, and also the different ways in which you want to model product. And at the beginning, you will actually choose what you want to include in the study. There are some shortcuts here where you can say it's just going to be a simple retail pack, or it's going to be a complete retail pack plus supply chain, or a full package and product. And this will then filter through your next stage when you come through to adding your modeling. If you've selected that consumer isn't going to be included, you won't have consumer stage represented in your tree diagram. It'll be hidden. So if you're just going to do a package with end of life, then all these other stages will be excluded from, and not cluttering up your modeling screen. So that's PK5, and now the timelines for all of this. So PK3 with the database updates and the new methods we will have in by the end of the month. I was hoping to have them in by today, but we'll give you a bit of warning that they are coming, because your results will change when we do that update. What we always do before a major data update is we will move the existing version of PK across to a separate website, separate server, so you can still get access to your old data to see how it was if you've got a project that you're finishing off, or you're confused about your new results and want to check it against the old results. So we'll do that. So that should all happen before the end of May. And then PK5, we're hoping to trial with selected users in September and go through any bug fixes or feedback with a full rollout by November 2023. That should have all the functionality, but then we'll be working on in the background the availability of the data and backend support for doing ISO reporting. So by early next year. And I think that's our main, what we're up to. Maria, yes, EF does equal PEF method. So the environmental footprint, yes, it started off being called the PEF, and for us working in product LCA, it's always the PEF, but then it became the environmental footprint method because it also applies to organizational footprinting. So. Okay, any questions or comments? Well, I hope that was useful. If you have suggestions, I think Gab is going to send around a survey, and so if you've got suggestions on what you'd like to see, so the future webinars won't just be focused on PK functionality, but we will present on different topics in the sort of more general LCA sphere, but related to how they represent in PK. So we look forward to seeing you then, if not beforehand.
And just on your note, Maria, we will be sending across the recordings before the end of the week. So that will be with you, and it'll also be online as well. But yeah, the next webinar is on Wednesday, the 14th of June. So hope to see you all then as well.